Okay, so hi everyone. Today we're going to see another problem, that is LeetCode 1143, longest common subsequence. It's a very standard problem, and it's a medium level problem, and it has a very good like to dislike ratio, which means it's a very good problem for learning. And I think in a lot of coding competitions, in a lot of interview scenarios, the problems, most of the problems falling into this category of topic comes as the variation of this one. So let's see what this problem is. So we are given two strings, text1 and text2. We need to return the length of the longest common subsequence. So what is the, first of all, let's see what is the longest common subsequence. If you have the string A, B, C, D, E and another, so this is string 1 and you have string 2 as, let's say, B, D, S, M. Yes, and now if you will try to form some sequence, then B is same in this string, D is same in this string, and other than that none of the character is same, which means that so it's there are two things for a subsequence. There are two things. One thing is the same characters, and the relative order should be maintained. So you can see that the subsequence of these S1 and S2 will be B and D, and you can see B and D are following this subsequence, and B and D are following the sequence as well in the S2. So this is the definition of a subsequence. And so if there is no common subsequence, so this is a common subsequence, right? Because B and D is a sequence that is present in the string 1 and it is present in string 2 and it is of the maximum length. Because B is also a common subsequence, but it is not of the maximum length, and the maximum length common subsequence will be, or the longest common subsequence as the question suggests, it is B and D, which is why the answer for this case will be returned as 2. So if we look at the test case 1, we have A, B, C, D and E, and then we have A, C and E. A and A is matching, C and E is matching, which means ACE is the subsequence of length 3 and 3 should be the answer, and it is the answer. Similarly, we have ABC and then we have ABC again. In both of the strings, all of the characters are matching, so the maximum longest common subsequence will be ABC, which is of the length 3, and the answer is 3 again. And in this case, we have ABC and DEF. This is the last test case, by the way. And in this character you will see A is not matching with anyone, B is not matching with anyone, C is not matching with anyone, which means the longest common subsequence is an empty string and the length of the empty string is 0, which is why the answer for this test case will be 0. Now I think we are done, we are clear with the question. So as of first glance, if you have no idea about the about this problem or the topic that it is associated with, then you might be thinking a greedy solution, that if we have a string, let's say A B C D E and we have ACE, then why shouldn't we use two pointers, and A is A matching? Okay, let's take A. Now you increment the pointer to B and you increment the pointer to C. But if you are using a greedy approach, this is the exact situation where greedy proof, you won't be able to give a proof for your greedy algorithm, because now you have two options. Either you can say that, okay, let's discard C and take E and process E, or you can also say that why not we discard B and take C, because if you will discard B and take C, then then you will have C, and if you will do it again, discarding every character in the string 1, you will have this string, right? And similarly for this string as well, you can achieve that thing, but there is no proof that which character should I discard. Should I discard the character, should I discard the character from string 1 or string 2? There is no proof, there is no detailed explanation which string should be preferred according to their length, their character, anything. There is no proof for that. So the very sure way for us is to, like process every possibility, process all possibilities, And when we are dealing with all possibilities, then we are using recursion. So let's see how this recursive code will work. So we have this test case A, B, C, D, E, and the other string was A, C, E, right? So you have this string. Now you will say that we are on the first element initially. Both of the elements are matching, which means that you will say that in your longest subsequence you have one element. So you will store this one element, and from this test case where you have these two strings, you will give your answer as 1. Now 1 is for the length of the the subsequence, because you have got one character that will surely be in the subsequence, that is A. But what about the other characters? So for the remaining characters, you will call the recursive function. So you were basically on A at that point, and now you will call the recursive solution for the remaining characters, and that is B, C, D, and E, and the other one is C and E, right? So at this point, you are pointing on B and you're pointing on C. Okay, now there's a confusion. Which character should I discard? So you will say, because it's a recursive solution, so you will have both the possibilities of discarding a character from string 1 or discarding a character from string 2. If you discard a character from string 1, then you will say that now I will be solving for, because B is discarded, I will be solving for C, D, E and C, E as it is, because now at this point string 1 character is discarded. And when you say that I will discard a character from string 2, then you will solve for B, C, D as it is, but C is discarded, so now you will process it for E, right? And out of these two values, because we want the longest subsequence length, right? So because of that, and this solve function will give you the length. So this is the length of the case where we are discarding a character from string 1, that is B, this B, and this is the case where we are discarding the character from string 2, that is this C. So in both of the cases, you will say that I will pick that one which will give me a max value. So that is why out of these two, you will have the maximum value. You will choose the one which has the maximum value. And at C at D, the pointer is pointing here. And at this point, you will say both of them are equal. So 1 plus of solve for the remaining string, that is D and E, and E at this point. And at this point, you will say that B and E, they are not matching, which means we again are going to consider two cases, that is S1 and S2, discarding a string from S1 and discarding a string from S2. So if we discard a string from S1, then it will be S of C, D, E and E. Otherwise, if you discard the string from S2, that is this E, then this will be B, C, D, E and an empty string. And for that empty string, I'll be just dash as a representation of an empty string. Now back to this call. So by the way, I'm doing this as a BFS, but it won't be BFS. We'll be doing in a DFS fashion. It's just a way of showing you that this is how calls will be made. Now at D and E, the pointer is pointing on the first element. At D and E, they are not matching. So we have two cases, either discard S1 or discard S2. So if we discard S1, then it will be E, comma E. If we discard S2, then it will be DE and blank, because E is now discarded. And at this point, C and E, they are not matching, which means we have again. So let's calculate it after some time. First let's calculate these values. Now E and E are matching, so you will say 1 plus of S, now dash, comma dash, which means empty string. And at this point, you will say that, so if one of the characters is having an empty string, then it means that you cannot form a subsequence with it, right? Because if you have, let's say, D and E and you have an empty string, you don't have anything, right? You won't be able to perform, or you will be able to form is subsequence, but that will be equal to an empty string, right? Because you have an empty string and that is equal to an empty string, and the length is equal to 0, which means at this point the subsequence, the longest subsequence that you can have is an empty string, and the length of an empty string is 0. So this call will return 0 as its value. And at this call, this will also return 0 because there is an empty string. If any of the string is an empty string, then the longest common subsequence will be an empty string and the length is 0. So the value that it will return is 0. And 1 plus 0 is equal to 0. Sorry, 1, right? And out of these two, the maximum value will be selected. And for this case, 1 and 0, maximum value is 1. So we will have 1 here. And at this point, it is 1 plus 1, that is 2. So this has a value of 2. right? This has a value of 2. Now let's solve this part. So we are at C and E, again two cases. If we take string, if we discard a character from string 1, then it will be D and and E as it is. If we discard a character from this side, this will be C, D, E and empty string. And at this point they are not matching, so we will be discarding. So if we discard S1, this will be E comma E. At S2 it will be an empty string, right? At this point this will return a value of 1, right? Because we have seen earlier S of E comma E will return value of 1, although there will be 1 plus of S empty string, and empty string S of empty string value will be equal to 0, which is why this is equal to 1, and you will have a value of 1 here. And at this point you will have a value equal to 0, and for this function you will have the maximum value as 1, right? And at this function you will have the value as 0, so which is why this is 0. Now let's solve this function. Because 1 is a empty string, this will have a value of 0. So now this is 0, and the maximum value out of 1 and 0 is going to be 1. And at this point the maximum value for this case is equal to 1, and out of these 1 and 2 the maximum value is 2, so you will have this as 2, and 1 plus 2 is equal to 3, so you will have your return value equal to 3, right? This is a recursive code. Now the time complexity for this code will be order of 2 raised to the power n. Why is it so? Because we are making two decisions, either to discard a character from string 1 or a discard character from string 2, which is why it's a 2 raised to the power n, and n is the size of the minimum. N is equal to minimum of string 1 size comma minimum of string 2 size. This is the value of n. Now let's solve this function. Let's solve this problem by a recursive code. But as you can see, the space complexity will also be equal to order of n. But you can see that time complexity is not a good thing, because 2 raised to the power 1000 is a very it's a very big value, and we cannot expect an OJ to accept the solution with 2 raised to the power n as a solution, right? So in order to solve this problem, we need to have some like optimization. And what we are doing currently is something called a plane recursion. And in order to optimize the plane recursion, we use the concept of DP. If you are not familiar with DP, then you can watch some other videos on this channel that are related to DP, and some of the standard problems are covered. Now let's back to this problem. So with DP we will be able to solve it, and we will see how optimization and how we will build a thought process for it. But first let's write a recursive code. So this is int n is equal to, let it be text, and this is string. T dot size int m is equal to s dot size. Now you have a, yeah, no, actually you don't need these sizes. You can just return a solve function, t s, 0 index for t, 0 index for s, and that's it. So you will have a solve function. This solve function will give you the maximum and the longest common subsequence length. So first argument is t, and then we have s, then we have I as the argument, as the index variable for t, and j is the index variable for s string. Now the base case is if any of these index is giving us an empty string, which means it's pointing on it's greater than or equal to its length, right? It's out of the bounds, which means if I is greater than or equal to t dot size, then it's a base case. Otherwise, or if j is less than or equal to s dot size, then it's a base case, and we will return the length of the subsequence as 0. Otherwise, if t of I is matching with s of j, then we will be returning 1 plus of solve for the t s I plus 1 and j plus 1. And if, yes, so now if we are So now there's a problem of discarding, right? Because which string should be discarded? I will say max because I'm returning length in my solve function. As a return type of my solve function is int, which means I'm returning the length. So the first variable is t s. Now, so if you are discarding I, the ith character, then you will move to the I plus 1th character and j will remain as it is. But if you are discarding the jth character, then I will remain as it is, that is I, and j will be incremented to the next character. And by this code, you will be able to solve this problem if there are no errors. Okay. Okay. But this will definitely give you a TLE. Why? Because it's a very bad it's a very bad time, it has a very bad time complexity. I think this will give you a TLE, this test case. Yes. So now in order to optimize this problem, because it's not a very viable solution, right? So what we will do is we will use the concept of dynamic programming. Every value that we are returning can be memoized, and the value that is memoized, and there is a high possibility, because there are some overlapping problems. I think you can go back in the video and you can see in the recursive tree there were some identical strings which we are doing again and again on the indexes. They are same indexes that were processed again and again. Their values were processed again and again, computed again. Why are we doing this when we can have memoize them, right? So I will say vector of int dp, and t dot size. Then we have a vector of int s dot size, and everything is initialized as -1. We will pass this dp as an argument here as well. Now, if we want to access the memoized value, then I will say that if dp of I and j is not equal to -1, which means that there is a value for them, then just give me that value rather than computing it again and again. And all these values that are returned should be memoized. So I will say dp of I and j is equal to this value, and if dp of I, and if there is some mismatching, then dp of I j should be equal to the max value in both of the test cases, in both of the possibilities, if we are discarding a character from string 1 or we are discarding a character from string 2. So I think this is fine. Let's see if this will work. Yeah, I should pass this argument as well, dp, and yes. Okay, it does work. Let's try submitting it. Okay. So this is a so this the optimize for from the plain recursion, we have optimized it to the memoization dp, also known as top down dp, right? Now let's memoize to even further, or optimize even further, and use a bottom up dp. Well, I don't really believe in this fact that it is even optimized, but in most of the compilers, how they are designed, the it's beneficial for us to use a iterative code rather than the recursive code, which is why still there is still some optimization that can be achieved with the help of the bottom up method. Now to run the bottom up method, first thing is, because bottom up we won't be relying on the indexes rather than the capacity or the elements that we have taken. That is this that is the main sequence, or the main crux of the bottom up dp. You have 0, and you will have a variable answer, that is no, not answer. We don't need any variable. So what you will do is you will start your for loop. So let's convert this top down method to bottom up. So you can see we are simply iterating over the element, right? We will be iterating over a string. So why not we iterate over the string 1 first, t dot size I plus plus. Now the next thing is, well, another thing is that it should be 1. Why? Because I is not the index in this case. I is the number of elements that we have taken from this string, right? Or the, yeah, the number of elements that we have taken, or up to how many elements we have done the processing in the string 1. That is the representation of I. That is the importance of I. That for that purpose we are using I. And then we have j, that is also equal to 1. J is less than s dot size j plus plus. Now there's a case if so if t of I minus 1, in order to access the index we need to subtract one of it from these variables, that is I and j, is equal to s of j minus 1. If the variables are equal, then dp of ij is equal to 1 plus of dp of I minus 1. That is why it's called bottom up, because we are taking values for the bottom from the upside of the data formation, and that is j minus 1. Else, if there's a mismatch, if the characters are not matching, if there's a mismatch, then the same thing at this point. As you can see, dp of ij is equal to I plus of dp of I minus 1 j minus 1. What I do is I just convert the same thing. Because it's a top down method, it will be plus, but in a bottom up it will be a minus thing. And dp of I and j is equal to, so let's convert this same thing. This will be equal to, so this value, how we are storing the solve of I plus 1 and j value. So I will say max of dp of I minus 1 and j, or dp of I j minus 1. And at last I will say access these values, and they should be, yeah, the last indexes should also be processed. Not indexes, but the size of the string variable should also be processed, that is t dot size and s dot size. And at last I will say that return me the t dot size and s dot size. So this dp, this state of dp, that is t dot size and s dot size, says that when all the characters of t are processed and s are processed, then tell me what is the longest subsequence that common subsequence that you have found. Okay, so yeah, this was it. Interesting. Oh, yeah, that's good. But it's one and the same thing. Now the time complexity for this part. So for the memoization, time complexity will be equal to s1 mod into s2 mod, and space complexity will also be same, time and space. And same is for the bottom up method, time and space complexity will be same, because but in memoization we are using a recursive stack plus the dp data structure or the 2D matrix. But in bottom up we are not using a recursive stack, we are using only a dp matrix, which is why it is a little bit optimized as compared to memoization. But on the time part it will be same, it will take the same time. So yeah, this was the problem. I hope it was helpful to you, and you can find the source code in the description. And if you want a specific problem to be solved or the intuition should be explained, then you can uh, write or give a link to that problem in the comment section. So anyways, thanks for watching and have a good day.